All right, welcome back, everybody. This week we're going to be looking at section 6.4, and we got two sections that we're going to be looking at in section 6.4. The first one is the sum and difference of cubes. That's what we're going to be looking at here. So I wanted to just review some factoring with our difference of squares. So first one, x squared minus 25 that we have over here. Again, when we're doing this, we want to ask ourselves what times itself gives us the first term, what times itself gives us the second term. What times itself gives us x squared, that's x times x. What times itself gives you 25, that's 5 and 5, so one's a plus, one's a minus. Those can be switched. You could have x minus 5 and x plus 5. That doesn't make a difference. Second one over here, again, what times itself gives you 9, or you could look at it as the square root of 9 or something like that. There's a couple different ways you can look at it. Either way, that's going to be a 3 and a 3. What times itself gives you x squared? That's x and x. One's a plus, one's a minus. Again, they could be switched. What times itself gives you 16? That's 4 and 4. Over here, first term, again, is a perfect square because it's x to the fourth. That means what times itself gives you x to the fourth? That's x squared times x squared. Remember, you would be adding those. 2 plus 2 will give you 4. One's a plus, one's a minus. I switched them up on this last one just to show you it does not matter the order. What number times itself gives you 36? That is 6 and 6. So what we are doing, the new thing for today, your sum and difference of cubes, here are your formulas. And basically what we're going to do is we're going to be given stuff in this form, a cubed plus b cubed or a cubed minus b cubed. And we're going to expand it out like this using one of these two forms. For the first one here, we're just going to expand it out, and then the second, third, and fourth examples, we'll actually set those equal to 0 and go through and solve them. One thing that I want you to remember is that we're actually going to come back to the quadratic formula. So why don't I actually just give that to you right here so you can have all your formulas on one page. So remember your quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac. And this whole thing is all over 2a. All right, and again, those are just formulas. We're plugging numbers in, and we're basically going to be taking, now this a, b, and c are a little different than this a, b, and c. There is no c here, but they're different than this a and b, so we don't want to think that this a right here is the same and this b. They're not the same as this a and b in this formula here, so it's a little different. But these are the formulas that we'll use here, so we just want to keep track of that. Just put them all there in one place, and we'll use them throughout these notes. So now coming down here in our first example, what we're going to do is we're just basically going to start off with taking this x cubed minus 8, and we're going to expand it out and just identify what our capital A, capital B, and capital C are. All right, so the first thing you want to do is you have to identify what is being cubed and in both of these parts. So just like in the bell ringers, we wanted to identify what is being squared. Here we just want to identify what's being cubed. So we have x cubed. It's a good idea to think of it like this. X cubed minus, well, what's this cubed? Well, that's the same thing as 2 cubed, right? 2 times 2 times 2 gives you 8. So now we know we can fill this in our difference of cubes. So we're looking at this bottom one here. And if you look up in my notes, I have same, different, always positive written there. What I'm referring to is the signs. So this sign is negative, and that's the same as this sign. The next one is positive. That's different from this sign. Okay, so there's your same, different. And this last one over here is always positive. Okay, so that's what I'm talking about when I say same, different, always positive. I'm referring to the comparison of these signs right here in comparison to the initial signs. Okay, so like they're the same here, they're both positive here. They're different, right? So this is a plus out here, and then this is different, that's a negative, and then this one's always a positive. So that's just an easy way to remember that if you ever have to memorize those formulas. You don't have to memorize them here, but I'm just saying if you ever do, same, different, always positive, just a good little thing to help you. All right, so the first one here, what we are left with is a minus b. Well, a is x minus b is 2. So we got x minus 2. And then parenthesis x squared, that's your first term squared, so x is just x squared. And then we have plus, and then we're going to multiply these two. Multiply x times 2, so that's just 2x. And then the last one's always positive. And then the last term is your b squared. So b is 2, so 2 squared is 4. Okay, and if you want to make a list off to the side, like with your a and b, you would say, well, a is x and b is 2. And then you can take and plug it in. Maybe that will help you to plug that into the formula a little bit easier there. You know, just one of those things, kind of like when we did the quadratic formula, we plugged them in. Just helps to make a little list sometimes. So we want to know what are the values of capital A. Well, that's 2. Capital B, well, that was also 2. And C was 4. Okay, just finishing out the problem here with answering the question, what are those values? All right, so let's move on. Next one here, we want to factor this. One more factoring problem before we get into the solving ones. And again, we want to think of this as what is our first term being cubed minus what is our second term being cubed. Okay, and this is going to give us our A and our B. So A is 2x, right? 2 cubed is 8, and then x cubed gives you your x cubed. And then the second one over here, 1 is just 1 cubed. All right, so that kind of helps you with, you know, saying b is 1, and then we also know that a is 2x. All right, so I'm going to rewrite the formula up here so we don't have to switch back and forth to that other slide. So if we have a cubed minus b cubed, which is what we have the difference, they're being subtracted. This is equal to a minus b times a, come on, there we go, a squared. This one's different, so plus a times b, always positive, plus b squared. Okay, so again, same, different, always positive. All right, so now we're just going to plug these in. All right, so I'm going to take here, I'm going to have parenthesis, a is 2x. So I'm just going to fill these in here. A is 2x minus, let me fill in my template here, and then I'll squared plus a times b plus b squared. All right, so now I can fill these in here hopefully. All right, so b is 1, and then we have a squared. Again, a is 2x, so put that in parentheses, 2x. Make sure you have it in parentheses, otherwise you're going to forget to square the 2, and you're just going to have 2x squared, and that's going to be wrong. That should be a 4x squared, because we have to remember to square both. And then we'll have a times b. Well, a is 2x times b, and b in this problem is just 1. And then we have b squared, which b again is just 1. All right, so that's kind of the messy part right there. Now we're going to just clean it all up. All right, so we'll just go through this last one more step here. First part has nothing to clean up, 2x minus 1. That's it. And then again, like I said here, don't forget everything needs to be squared. So it's not 2x squared, we have to square that too to make it 4x squared. 2x times 1 just gives you 2x, so plus 2x. And then 1 squared is just 1, so plus 1. Okay, and that is your final answer there, what you see written all in blue. That is going to be your final answer for number 2, or example number 2, I should say. Okay, and again, if at any point in time during these problems you need to pause, rewind, go back, double check, if you're lost at all, make sure that you do that so you can follow along with what's happening. All right, now for number 3 and 4, we are going to solve this. All right, so this is where your quadratic formula are going to come into play, because we want to find the complex roots for this. So we're going to go back to a couple of other things that we've done in the past. All right, so let's first of all, this is a sum as a plus, but we need to first of all, we need to know what is our A and what is our B. So we need something cubed. Well, this is 3x cubed. 3 cubed is 27. X cubed is x cubed. And then we got 1 cubed gives us 1. Now, the only difference here in the setup is this will be equal to 0, so we have to make sure we write that down when we do our second part. So now, just starting this off here, let me switch up the color here. We're gonna go back to our formula again, which again, let me write this down. We're just starting this off, so I'm gonna write it down a couple of times. A cubed plus B cubed. That's what we're starting with. Equals, this is what we're gonna write. A plus B times A squared minus AB plus B squared. All right, now I know some of you can do all that stuff in your head and just jump right to the next step, but I'm still going to show all my little steps so everyone can follow along with what's happening here. So first up, A. Well, A is 3x plus B is 1 times A squared. So A is 3x squared minus A is, again, 3x times B is 1 plus B squared. And now again, we don't want to forget that this is equal to 0. Okay, that's still part of our problem here. We want to make sure we include that. All right, now we are now ready to simplify this, and then we will set each part equal to 0. So again, the first part here, nothing to do with cleaning that up. We just got 3x plus 1. Second one here, we do have some work to do. 3x squared, again, don't forget to square both of those. All right, so 3 squared is 9x squared. And then minus 3x times 1 is 3x. And then plus 1 squared just gives you 1 equals 0. All right, so that is just using your sum of cubes right there. All right, so that's really the new thing. The rest of this is repeat. It's just kind of a next level of repeated material. So this is where it gets a little bit more challenging. So if you remember from before, wherever we have a multiplication, right here, that's where we split it up. So we say 3x plus 1 equals 0. This is super easy to solve. All we're going to do is get rid of this 1. We do minus 1, minus 1. This is really easy. We did a lot of these problems in Algebra 1, two-step equations. There's nothing difficult about these. Okay, so divide by 3, x equals negative 1/3. Okay, final answer for that part. Now we're asked to find the complex roots. That's not a complex root, that's a rational root. But I'm just going to include that as part of my answer for now, because later on we're going to have to include all of them anyway, so I'm just going to include it right now. But that is not a complex answer. This second part, what I did not mention yet, is this second part over here. This will always give you imaginary answers, okay? And those are your complex solutions. So when it says to find the complex numbers, or complex solutions, this is really all they want you to solve, is this part up here. All right, so basically the way that we're going to solve that is using our quadratic formula. All right, so let me change up the color one more time. And this is where we're going to use A, B, and C for the quadratic formula. So let me just rewrite that over here. X equals negative b plus or minus square root of b squared minus 4ac. And this is all divided by 2a. Or if you choose and you were like a huge fan of completing the square, you can do completing the square. Those are your two options with this, because this will not factor nicely. So completing the square or quadratic formula, those are your two options. Like I said, I think most of you would probably prefer quadratic formula. especially since right there is your formula that you can use. So go ahead and use your quadratic formula. That's what I would suggest. Okay, so now this is where we're going to list A, B, and C, and then we'll plug it into that formula. So now this is a new set of A and B. This is not the A and B from up above, like A is 3x and B is 1. That's not the same A and B. A here is 9. Try to make my A and my 9 look a little different there. I was a little drastic with my 9. B is a negative 3, and C is 1, okay? So those are the values that we'll use to plug into our quadratic formula. All right, so x equals negative, b is negative 3. Remember, when we do quadratic formula, there should be no x's in that formula. We should just end up with numbers. Sometimes we're going to end up with an I, but there should be no x's over there. So plus or minus square root of b squared, so negative 3 squared minus 4 times A is 9 times C is 1. And this is all divided by 2A, which is 2 times 9. Again, try to make my 9 look a little more like a 9 and a little less like an A. All right, now let's finish this out. So x equals, we got double negative there, so that's 3 plus or minus underneath the square root. Let's see what we have here. Again, you could just plug all this into your calculator and see what you get. Don't use the square root because it'll just give you a decimal, which we don't want. So 3 squared is 9, right? So we have 9 minus 4 times 9 is 36. So what do we get there? Again, like I said, you could just plug that into your calculator. But 9 minus 36 is going to give you 27, or in this case, a negative 27, which, like I said, these are all going to give you imaginary numbers. All right, so, and 2 times 9 is 18. All right, now 27 is a square root that can be reduced. All right, so we want to simplify this. So 3 plus or minus, that can be reduced. The square root of negative 27 is going to reduce to 3i square root of 3, all divided by 18. And then if you remember, all of these numbers on the outside are all reducible. Okay, so I'm talking about the 3's on the outside, which is this 3, and the 18. Those are all divisible by 3. So final answer here, 1 plus or minus I square root of 3 divided by 6. Final answer. And that is what they wanted. That's your complex solutions. Okay. So again, this over here, this is not a complex solution. This is just your rational solution. This is your real solution. But these two are your complex imaginary solutions. Okay, so the next problem over here, what I would suggest you do is pause the video, try to do it on your own, see how you do, and then come back and just check and see if you got the right answer. So that's what I would suggest you do. But if not, if you want to just follow along with us, you can do that, but that's up to you. So I'm going to do this problem here now. So again, we got difference, this is the sum of cubes. So this is x cubed plus 3 cubed. Okay, so we're left with x plus 3, and then it's going to be a squared, so x squared minus a times b, so 3x, plus, always positive, b squared, so 9, equals 0. So again, we did 3 of those sum and difference of cubes, so I skipped a few steps there getting down to that point, but that's what you should get there after you plug those values in. So now this just says to solve, so we need all of our solutions now. So x plus 3 equals 0. Again, very simple here. All we have to do is move the 3 over, so subtract 3. X equals negative 3. There is one solution. We are not told to just find the complex, imaginary, real, rational, whatever. We're just said to solve, so we have to find all of them here now. For the other part here, again, we're going to use quadratic formula. In this case, A is 1, B is -3, and C is 9. All right, so we're going to take that and plug it in. So x equals negative b is -3 plus or minus square root of b squared, so -3 squared, minus 4 times a is 1 times c is 9. There we go. All of this is divided by 2 times a, so 2. A is 1 for this problem. Alright, so let's clean this one up here. We actually end up getting the same thing here. Square root of -20. Whoa. Sorry, my tablet's kind of freaking out here. Let's try that again. Because you get 9 minus 36 again, so we're going to end up getting a -27, which is what we got in that last problem. So, same thing there. Easy math if we just did it in the last problem. Don't really have to do it again. Okay, so we don't have any way of simplifying the overall fraction, but we do still need to simplify our square root. So 3 plus or minus 3i square root of 3 all over 2. So there's your final answer, what you see boxed in blue and boxed in green. Those are both part of your final answers. Again, like always, if you ever have any questions, send me an email, let me know, and I'll do my best to get back to you as soon as possible. Rewind the video. If you have any questions, try to see if you can figure out where I lost you. But if you're still lost and still confused, just send me an email and let me know. Try the homework problems and just let me know if you have any questions.